This is Mr. Anderson for Kellogg Community College. We're going to be looking at some possible problems that will show up on your Chapter 3 and Chapter 4 test. This is to walk you through the worksheets and the solutions that we have for that. We're going to start off today with looking at graphing and finding intersections through graphing and also through substitution and elimination. Now, the first problems here we have to practice are looking at how to solve systems graphically. We're looking to see if these cross at a point or if they don't cross at all. Now, to get these onto our screen here, the easiest way to do that is to solve for y and get this into y equals mx plus b form. Now, the first equation is almost in y equals mx plus b form, but there's a 2 in front of the y, so we're going to divide everything by 2. And since it's a monomial, what we can do is just divide everything by that 2 there. So we have y plus, or y is equal to 3 halves x plus 2 1/2, or 5 halves. Now, to draw your graph of this, what you have to do is start your y-intercept at 2 1/2, which is right here. And from that dot, we're going to move up 3 and over 2. So that's going to be up 1, 2, 3, and over 2. Now, since we've run out of room here, we can also go down 3, 1, 2, 3, and over 2, and we have our straight line. Now, it's important to use a straight edge here on your test, most likely because you want to see the intersection point very cleanly on the screen. Now, the second equation is also very close to being in y equals mx plus b form, so we'll move the 3 to the other side by adding 3, and what we get is y equals ax plus 3. And the slope in front of x is 1 over 1. So we're going to start off at 3, 1, 2, 3, and we're going to move up 1 over 1. And we can see that very quickly we will have an intersection right there at the second point of this straight line. So the intersection is right here, and that's going to be at 1, 4. It'll note that you're probably going to have some easy intersections on this part of the test because I don't want to grade something that's really tricky to see from your part and my part. This is a consistent problem because there is an answer, and these lines are independent. They're not overlapping. Now, in this situation here, we have another problem where the y's are not by themselves. In this problem, the first equation will need to move the 6x to the other side, so minus 2y is equal to negative 6x plus 2. That's subtracting the 6x from both sides. Dividing by negative 2, and since negative 2 is a monomial, I can give each of those to each of these to the terms. Let's go divide those out. Y is equal to 3x minus 1. So there's our first equation, y equals 3x minus 1. So we're going to go down 1, and then we're going to go up 3, 1, 2, 3, because the slope is 3 over 1. 1, 2, 3, and over 1. 1, 2, 3, and over 1. Okay, so let's go connect the dots. Connect the dots. And then still, it's probably a good idea to go to back 3 and down 1. Back 3 and down 1 down here. Alright, so now that's as far as we go. Now the next equation, I'm going to divide by negative 3 on both sides. Now, since it's monomial, I can divide each of these by negative 3. So what I have here is y, this is my second equation, is equal to 2x minus 3. So this is going to start at negative 3, 1, 2, 3, and it's going to go up 2 over 1, up 2 over 1, up 2 over 1. Now what you might notice is that these lines are actually getting further apart from each other the more you go up. So what we do is we have to go down and see where they intersect. And sadly, they intersect right off the screen there at the bottom. They intersect right below the grid at negative 2, negative 7. This probably won't happen to you on the test because I'll definitely make sure that the lines do intersect appropriately on the grid that I've created. But this, if you do create straight lines, will make consistent graphs because they are two lines that intersect at one point, and these are independent lines. Again, to remind ourselves about these words here, we're going to see some different examples as we go through this first part of the video. Alright, now we're going to get away from graphing and we're going to go to the strict algebra here. Though some teachers may give you some options as to what methods to use, whether you're going to use substitution or elimination throughout this worksheet here, I will show you the method that's actually written on this worksheet just to give you a variety. But again, any of these problems can be manipulated to be used with substitution or elimination. Now, the reason why we choose substitution here is because there's this all by itself there. So the y is all alone, so we're going to plug that into the variable y. So what we have is 9x minus 2 parentheses 3x minus 6 equals 3. And we're going to solve for x. Once we solve for x, we can plug this into my y and get my answer. Now, I can distribute the negative 2 here, and this is probably the biggest trick of the problem because a lot of us will miss the fact that it is a minus 2. So this is going to be 9x minus 6x plus 12 equals 3. The 9x minus 6x is 3x plus 12 equals 3. We're going to move the 12 to the other side, so 3x, if we subtract 12 from both sides, 3x is equal to negative 9. Divide both sides by 3, x is equal to negative 3. So our first part of our solution is negative 3. Now our second part of our solution is to plug the negative 3 into our x and solve for y. And that's really handy right here because we have our 3x minus 6 equals y. And since we have that, we're going to plug that negative 3 in for the x right there. So 3 times negative 3 minus 6 equals y. So we have negative 9 minus 6 equals y, or negative 15 equals y. And so the answer is negative 15. This is a consistent answer again because it does have an answer. If we didn't have an answer, this would be inconsistent. And these are two independent lines because it has one solution. So consistent and independent again. Now once we go to the next page here, we're going to have some problems that are not necessarily going to work that way. So let's go to the next problem. It's a little bit different than the last problem we dealt with because even though we're going to use the substitution method, you'll notice that this problem might be better as a stacked problem using elimination. But what we can do is easily take this equation right here and get the x all by itself. We can say x is equal to 3y plus 7, and then take that 3y plus 7 and plug it in for the x. So what this gives me, it gives me 5 times 3y plus 7 plus 6y equals 14. Now again, you could have solved this problem using the elimination method, but since I'm sticking with what the problem is telling me to do, I'm going to choose to do it this way. Alright, so I distribute the 5, that's 15y and 35, plus 6y equals 14. 15 and 6 make 21y, and I'm going to have my plus 35 equals 14. Now I'm going to subtract my 35 from both sides. Alright, so I get 21y is equal to negative 21. Divide both sides by 21. Y is equal to negative 1. Alright, so there it is. Y is equal to negative 1. So in my solution set, I'm going to have an answer of negative 1. Now I just plug that in for y, and I think I should do it to this equation right here, right below where I kind of manipulated that in the first place. So I get x is equal to 3 times negative 1 plus 7. So this is x equals negative 3 plus 7. X is equal to positive 4. This is another consistent independent answer. It's consistent because there is an answer, and it's independent because there were two lines. Now let's go take a look at the next problem. Next problem talks about using only the elimination method. Alright, so the elimination method is going to take into account when we multiply the top and bottom line by something where we can get either the x's or the y's to cancel out, or simplify to 0. Canceling is kind of the non-correct terminology there. But we're going to simplify the x's here, I think, or and that because I can see that 8 and 6 can both be made into 24. So what I'm going to do is multiply the top line by 3 and the bottom line by negative 4. Now the reason why I choose to multiply the bottom line by negative 4 is I prefer adding versus subtracting. So this will give me negative numbers in the bottom, which I can easily add up to give me my answer in the numerator. Or not the numerator, the first line, or the first part there. Now if I multiply everything by 3, I'm going to get 24x plus 36y equals 48. Multiply this by negative 4, I get negative 24x minus 36y equals negative 48. Now what happens when I bring this together, these simplify to 0 and this simplifies to 0. So my solution is sloppily all solutions because these are the same lines, but what we have to do is we have to tighten up our answer here and say, well, for x and y, this is the equation for the problem. You pick one of your two equations and you write it down inside of the set brackets there, which tells me that these are the solution sets right there. You can't just say any real number because it has to fit into this rule for that pair of numbers to be the answer to the problem. This is definitely consistent because there's an answer, but these are dependent lines because these are two of the same lines. Now, it's possible to actually have a problem very similar to this, and some of you will have this possibility on the test, that you get to a problem, and let's say you solve where you have, like maybe, this is, again, another example here, 4x minus 3y is equal to 10, and then you have negative 4x plus 3y is equal to 12. When you add these up, these simplify to make 0, and this doesn't make 0. And in a situation like this, there would be no solution. So inside of the solution blank, you could just put the empty set because there is no answer to the problem. And these are inconsistent, independent problems. And they're inconsistent because they don't have an answer, and they're independent because they are two separate lines. They are actually parallel if you graph them. So if you have a situation like this, you're going to have inconsistent, independent lines. Alright, now this problem here, number 6, we're going to solve using only the elimination method. So now this one is not going to work out to a no solution, all solution problem. So what we can see is there's probably a smart way to get rid of the variables. And it would be better, in my opinion, to eliminate the y's just because they're already opposites. Although it is completely legitimate to eliminate the x's, but you would multiply the top by -2, the bottom by -5. So what you're going to have here, your top is going to be multiplied by 8, and your bottom is going to be multiplied by 7. So this gives me 40x minus 56y is equal to -128. That's multiplying the top line by 8. The bottom line multiplied by 7, we've got 14x plus 56y is equal to 182. And then we're going to see, by adding these up, this is 54x, these simplify, this makes a total of 54, dividing both sides by 54. X is equal to 1. And that's good. My solution has a set of 1, and already I can say that I'm going to have a consistent answer, and these are independent lines. But now we have to solve for y. Now, where would I plug this 1 back into the equation? You can choose either equations, and the bottom one would be the better bet because it has fewer negatives. So 2 times 1 plus 8y is equal to 26. This is to solve for my y. So 2 plus 8y is equal to 26. 8y is equal to 24 if I subtract 2 from both sides and divide both sides by 8. Y is equal to 24 divided by 8, and 24 divided by 8 is 3. So my answer is 1, 3. There's my solution set. For the last part of the video here today, we're going to take a look at the three-dimensional problems where we're going to have x, y, and z. And we're going to see how these work out, and I'm going to show you these and how I'm going to do them in about 4 steps. Again, there's about half a page here. You'll have one of these on your test, and you'll be given the whole page in case you make a mistake. There's no need for scrap paper since you'll have the whole sheet. The first thing you should do is probably identify which problems to pick and which variables to eliminate. The variable I would eliminate or go after is y, because by choosing the second and third equations without doing any manipulation, so x plus y minus 3z equals 4, and 2x minus y plus z equals -14. You can see that I have opposites of the y's, so just by adding them up, I'll get 3x, the y's go away, and this is going to be -2z equals -10. Alright, so this is my first step, is to pick two equations and eliminate my y's. Now my second step has to be picking another 2 equations and eliminate y's again. So we're going to pick I'm going to pick the top equation, since it has a positive y value, in this case 3y. And I'm going to pick the bottom equation because it has an opposite or a negative y, but I will multiply by 3, and in doing so this makes 6x minus 3y plus 3z equals -42. And in doing so here, this gives me opposite y's, so those go away. So I have 8x, and then I have 4z, and then I have -36. Now this is my second step. We've eliminated y's, And so what we're going to do is, for my third step here, is I'm going to put together these two equations with x's and z's in them. Now the equation, now the number that's going to get eliminated is this z, because this is a negative 2z, this is a positive 4z. So if I take this branch and multiply it by 2, I get 6x minus 4z equals negative 20. And if I take this branch and do, well, nothing to it, then I get 8x plus 4z equals negative 36. And then these z's go away, and what I'm left with is 14x is equal to negative 56. Now luckily, if I divide everything by 14, x is going to give me a whole number, which is negative 4. So there's that. Now that's giving me a little bit of confidence, because I should be getting whole numbers for these, because I'm not really trying to throw any horrible decimals at you here. And if you are going to get a decimal, it's going to be a 0.5 or a 0.25, nothing that you can't handle. Now, once I get, for my step 3, my x, then I go back to either my equations from steps 1 and 2, and I can solve for z. In fact, for step 4 here, I'm going to take this 8x plus 4z equals negative 36. I'm going to take this, and I'm going to plug my negative 4 in for that x right there, so I can solve for z. So this is going to be 8 times negative 4 plus 4z equals negative 36. So this is negative 32 plus 4z equals negative 36. I'm going to add the 32 to both sides. 4z is equal to negative 4. Oh, nice. And then I divide both sides by 4. My z is equal to negative 1. So here I have two answers to my three-part problem, because I need it, or three-answer problem, because I need my x, y, and z. And now I'm going to take my negative 4, negative 1, and go back to my original equation for step 5, and plug x and z back into one of these three equations. My suggestion is to pick the equation that has the fewest number of negatives. In this case, it would be the top line. So we're going to go 2 times negative 4 plus 3y plus negative 1 for the z equals 6. Do some simplification. Negative 8 plus 3y minus 1 equals 6. Move the negative 1 and the 8 together, so 3y minus 9 equals 6. Move the 9 to the other side. 3y is equal to 3. Divide both sides by 3. Y is equal to 1. So my answer to this problem is going to be the, whoops, I think I made a mistake here. Hold on. 6 and, hold on, I did. 6 and 9 make 15, and then 15 divided by 3 is 5. Whoops, sorry about that. I'm not going to edit that one out. So my answer to this problem is going to be negative 4 and 5 and negative 1. All right, moving on to problem 8. This will be our final one in the video here today. This is another three-part problem here, or five-step problem for 3 answers. And I think I'm going to eliminate my y's in this case. And the reason why, by just looking at the first 2 problems here, like this one and this one, by just looking at them, I can just see that if I take them and stack them on top of each other, that is going to give me my simplified answer where the y's will be simplified. Oops, forgot my, it's not a 5, that's a z there. Alright, equals 22. Okay, so what I have is my 3x, my y's go away, plus 9z equals 27. Okay, so my step 1 was just picking 2 and eliminating them. Now what I'm going to do is probably pick these 2, because the y's are both opposites, but I'm going to have to multiply the bottom line by 3, so I get these opposite y's to simplify to 0. X was 3y plus 8z equals 22. This is my step 2 here. And this is 3x minus y plus 2z equals 12. Alright, stack them on top of each other. I got 4x, I've got minus 2y, and I have, whoops, crap, I forgot to multiply the bottom line by 3. Why didn't you say something? Oh, you can't. Alright, so here's 9x minus 3y plus 6z, ugh, and this is going to be 36. Boo. Alright, not going to edit that one out. Alright, here we go. So these two get added together to make 10x. The y's simplify, and this is going to be 14z, and this is going to be 58. Alright, now for step 3, I'm going to bring these two equations together. Here's the real thing, though. There are no easy picks here because all of these are positive. Like these are all positive numbers, these are all positive numbers, and since they're all positive, I'm going to have to choose a variable to eliminate. I'm going to eliminate the x's. Now that means I'm going to have to multiply my top line by, let's multiply the top line by negative 10. And if I'm going to have to choose one of them to be negative, I might as well choose multiplying by 10. And then the bottom line is going to get multiplied by 3. So this is going to give me negative 30x. This is going to give me negative 90z. And this is going to give me negative 270. Now down below here, multiplying by 3, this is going to give me 30x. That's why I chose them, so the x's would simplify to 0. This gives me a positive 42z, and this is going to give me a positive 174. Thank goodness for calculators, right? These get simplified. This makes a negative 48z, and this makes a positive 96. Dividing everything, let's see, does it make a positive 96? Nope, negative 96, sorry about that. Dividing everything by negative 48, dividing by negative 48, negative 96 divided by negative 48, z is equal to, hold your breath, 2. All right, now we can plug that 2. See, this is my third step. For my fourth step, we can plug that 2 back into one of our two equations here. I'll choose this top one here just because the numbers were a little bit smaller than this one down here. So I'm going to go 3x plus 9 times 2. And that's going to give me, and this is equal to 27. So this is 3x plus 18 equals 27. I'm going to subtract 18 from both sides, so 3x equals 9. Divide both sides by 3, x is equal to 3. All right, so we're down with 2 of our 3-part answer here for our 5-step problem. Our 5th step is to choose one of our 3 equations from up above, plug our x and z into it, and solve for y. The middle line here has the fewest number of negatives, so let's do that one. Let's go x plus 3y plus 8z equals 22. So this means I'm going to plug my 3 in for x, 3y plus 8 and 2 in for z, and 22. So 3 plus 3y plus 16 equals 22. Do some simplification. 3y plus 19 equals 22. I'm running out of room here, so let me just kind of bring this back up here. 3y plus 19 equals 22. Alright, so here's what I'm going to do. Subtract 19 from both sides. 3y is equal to 3. Divide both sides by 3. Y is equal to 1. So my answer is 1. So my solution set for this problem is the point 3, 1, 2. 3, 1, 2. Well, thanks for watching, and hope this has been helpful. Please email me if you have any questions.